My name is Anton. I actually work for JetBrains as a developer advocate for TeamCity. So I am not a developer of Kotlin, the language or the compiler. We just use Kotlin in some of the products. And in TeamCity, you can write build configurations. Like if you have used Jenkins before, then you can write this Jenkins file, which is in Groovy. In TeamCity, we have a similar thing, but in Kotlin instead. If you don't follow me for some weird reasons, here's your chance, right? So I don't think it will take even just less than an hour, but maybe even less than half an hour, and we probably can talk about some other topics. But we will see how it goes. Maybe you will have questions, and it will take longer time. So okay, I introduced myself. I don't know anything about you. Are you Java developers mostly here? Java developers. Okay, I know most of you now use IntelliJ as well. Kotlin, who uses Kotlin? A lot of people. Are you using Kotlin professionally, or are you just trying it out professionally? Okay, so most of you actually know Kotlin better than me, because I'm a professional Hello World developer, because I'm a developer advocate. I don't really write code into the products. I demo the code, right? But anyways. So if you are into Kotlin already and you have experience in programming, you probably have seen talks about DSLs, just any, not only about Kotlin DSL, anything. Do you know anything about DSLs, like what it is used for? Some people, like 50% of the room. Why did you come here? What do you want to learn? Okay, anyways. So normally, through the years, there's like, I think for the past 10 years, I've been regularly seeing and hearing someone talking about DSLs in one context or another. And somehow historically, it was mostly the area, especially like the area when you apply DSLs to something, then it's mostly about learning some new language, or if it's internal DSL, then it must be most likely a dynamic language. And when you come and talk about DSLs to people who have already heard about DSLs in the past, they are kind of really skeptical about it. And why are you talking about DSL again? That's so horrible. We want a better programming language instead. So yeah, like if we try to generalize the DSLs, right? We have two groups of DSLs. The first one that is external, where you develop a grammar, maybe, in most cases, and then you have like a fully fledged programming language that is tailored for the specific task, right? You can probably think of some examples. Ant, anyone? Basically a DSL, right? So built for building something, or CSS. That's also a DSL for something, for a specific task. You don't really, okay, you probably can program something else in CSS these days, but as a normal person, you probably wouldn't. And the other group of DSLs is the internal ones that are embedded in the language. So you have like a host language, and then you kind of don't really develop a grammar, but you develop a vocabulary instead. So you don't have a parser, you don't generate any extra code for that. Then you just can embed this vocabulary into different parts of your program and can even intermix it, and then make the program somehow readable to yourself or to your colleagues, depending on the task. And this is what we are talking about today with Kotlin DSL. In many cases, I even think that it's not fair to call this kind of things a DSL. It's just a syntactic sugar that is enabled by the features of the language. So for instance, like if I will show you a few examples right now of Kotlin DSLs, of different Kotlin DSLs that are, exist out there, more popular ones and not so popular ones. Have you seen this one already? those who are interested in Kotlin must have seen it because it's like one of the popular ones. And it's, as you see, well, you probably cannot, but it comes from Kotlin itself, so it's just from Kotlin extensions. At JetBrains, we have developed a few components and a few libraries for writing better code in Kotlin, so this is one of them. This is pretty simple, right? There is something a little bit more complicated, also coming from JetBrains, Anko, which is probably mostly known by Android developers. Have you seen this one? Anyone? A couple of people, yeah. So looks really nice as well. Another one, Gradle Kotlin DSL, everybody knows it, right? Everybody knows it. Okay, make some noise. All right. By the way, I think it's soon to be 1.0, if it wasn't yet, right? So it's going to be general availability soon. Spec. This is a nice testing library. I haven't used it, and it actually looks weird in some places. Like, why should I write this it in there? I don't know. Assert equals just enough. But anyways, just another example. Exposed, also by JetBrains. That's the DSL for accessing databases. Looks nice. Readable. Another one, that's just a hobby project from someone at GitHub to write layouts for Vaadin framework. If you have heard about Vaadin, you know, the code in it looks like you're mostly working to create a layout in Java, right? Almost like in Swing, but in Vaadin it's like a similar programming model. So if you compare Anko, that was in the previous slide, to this one, they look pretty similar. It's just that have like different vocabulary a little bit. Another one, again, one of our former colleagues developed Kubernetes Cotton Dsl, so that it talks to the APIs and you can define the configurations in Kotlin instead of YAML, for instance. I mentioned TeamCity, so we have our own DSL for that as well. So you can define a build configuration, how to connect to source control repository, define artifacts, define build steps, triggers, dependencies between build jobs, and so on. So you get support from Kotlin DSL to configure your CI. Another one, Ktor. Have you heard about Ktor? That's also from JetBrains. That's like an asynchronous web framework for developing web applications. And as you can see, it's intermixed here. The HTML library that was on the first slide, in the first example, it's also here. So we are intermixing two vocabularies in the same program, in the same code. Okay. So they actually look very similar if you have been watching carefully. How similar they are? Can someone tell what is the similarity?
There is nesting.
Okay. Anything else? By nesting you mean there is like a term, there is like a braces, then you put another term, so we get a structure, right?
They all seem to create some kind of hierarchy of objects from a few predefined types by nesting them.
Well, almost. It seems like that, but some of them actually execute the code. For instance, exposed, in some places it builds the structure, builds the kind of object graph, but in some places the same structure executes. So it's not completely true that it builds the objects, it depends on the purpose, but the structure, how it looks like, is really similar, and they have nesting. So, and it's really not a new language, right? So it's such a syntactic sugar that you get from Kotlin to get this kind of structure. And this is what we are going to talk about today in the demo, how to achieve that, what are the small syntactic features in Kotlin to actually provide this kind of structure and enable it in your programs. So, as you already said, there is nesting. Like generally, they're similar in the way that there is like some term. It opens a Lambda. There is another term. It also opens a Lambda. Then there is like a field or like some assignment, let's say, of a value to some field. Then there is a field that could be assigned a result of a method, which is actually a method call, right? That uses a Lambda inside and so on. So it can be nesting further on and further on. And then there are some other things that we can use. And obviously, like it works in the IDE with all the syntax coloring and in a type-safe way, which is very important. Because have you tried programming the DSLs in Groovy, or have you tried programming in Groovy? No, because this is very similar to what you can achieve in Groovy syntax-wise and structure-wise, but it works differently. It resolves the method calls at runtime instead of compile time, so it's not statically typed. It's very hard to achieve a good completion from the IDE. Good safety net is missing, basically. With Kotlin, you get it kind of out of the box, because this is Kotlin. It's valid syntax, right? It's just a matter how we structure the code to achieve this kind of structure. Okay, let's write some code, actually. I have a little example for you. And here's some Java code. I hope everybody can see it, right? I've made it maximum size. We can do it like this. Okay, so this is a Java code, and imagine that this code comes from the library. You are not able to change the sources, right? So this is something that we have in the library. We don't have the control over it, and we just use those classes. And this is a pretty good code, right, in Java. It's not something really terrible, I would say. It's fine. Like, before I started programming in Kotlin, I thought that those little things that Kotlin provides are not really important to me, like the new keyword, right? Why would I care? But when I tried Kotlin for a couple of months and I came back to Java and I had to type the new keyword again, I was like, damn. What semicolons, what the shit. Okay. Anyways, let's try and see what can we do with this code to achieve the DSL-like structure in Kotlin. So I just copy this code. And by the way, I probably should show what it does. So we have a builder with all those getters and setters and fields, and a build method that actually creates the client from the fields that we set through the builder. Then we have some other builders that are used in the parent builder and so on. So it kind of creates an object graph again, right? So it's very canonical example in our case. So I just copy this code. Shall I probably take a seat this time? And I go to the Kotlin file instead. I have a main function just here. And what I'm going to do is to just paste this code first, and the IDE will suggest, hey, could you convert? Do you want to convert it? And for those who are unfamiliar with it yet, you should notice a few things, right? So in Kotlin, we don't really call getters and setters. The compiler does it for us because we have properties. We don't have the new keyword, right? This is the one thing that I was annoyed by. There are some other things, right? We don't have to write the type on the left. If we want to write the type explicitly, we can do that. Client builder, but we don't have to, and so on. So this code is slightly shorter, but did we get any benefit out of it? Not really, right? It kind of looks better, but just a few characters. We didn't change anything, and we don't have a nesting structure. So what we can do now, just start small, right? We don't start creating this nesting right away, but we start to play with it before we actually proceed to this kind of DSL-like things. Let's execute it first. So, and well, we have this printed, right? So we have created a client, and it doesn't have a toString method. and we cannot change the library, right? This is the class that comes from the library, we cannot change it. And we want it to be pretty printed. So why don't we add some kind of a utility method to print it? Maybe it would be nice to have something like this. Client to console string. It would be possible to define our own toString methods. If you're familiar with Kotlin, you know we can add the extension method, right? But it's not really a good idea, because if you update the library and there is a new toString method, your extension method will kind of collide with it, with the original one, and probably this is not intended behavior by either the library out there or yourself. So why don't we add an extension method that is called somewhat differently? Okay, string. Okay, to console string, and maybe we can just print something like client. Oh, sorry, it added to the wrong place. We want to go back actually. So fun client to console string. Okay, I'm a bad typist, as you see. Probably should scroll a little bit so that everybody can see it on the top. And then return a string, right? So the type will be inferred, so it will be a string. And so what could we print there? For instance, this Twitter handle plus this company name, right? String. Okay, so this is not required because we are in the context of the client, so this is not needed. And if we really want to, we can actually convert it to template, which is a little bit shorter, so that we don't have any pluses there. Okay, let me close it. But this is something that we can even improve a little bit. What if we don't want to type those braces, right? This is like extension property that we want to add this time. So while instead of to console string, we will just have console string and client console string, which is string, and then we get add a getter and just copy this thing from here, right? Kind of the same thing, but already is nicer somewhat. And we can either move it back to the string, or it's a matter of taste. Well, what is better? I think just in this case concatenation is somewhat more readable. Okay, so here we had two things. We learned two things, right? We can do extensions, either extending with the method or the property. And this is like a fundamental block for the DSLs, actually. This is like the fundament from where we proceed building the DSLs, because whatever we add, whatever vocabulary we add to the new, to the classes that already exist, they are extensions. And this is what enables it. So now we didn't really change the code much. What if you remember in those examples that I had, almost everything started with some sort of a call, like create HTML, for instance, right? So why don't we have the same? Why don't we have something like client? No, start from here. Val client create client. Right? We don't have it yet. And then we could be able to add extensions on top of that. Let me show you what I mean here. So let's start with the method first. And it will give us the client. And what shall we use here? What should be the parameter be? So in Java 8, they added a consumer interface. And we could actually apply it here. Let me show you what consumer is. Consumer, it's a generic one, so we actually would have to use the builder to generify it, client builder. And if we go to the spec, let me see. The interface represents the operation that accepts the simple input argument and returns the result. So we send the implementation of the interface into the method, right? And then obviously the method should actually call that implementation. So if we go back, so we work with the client builder equals builder client builder. No, we should create an instance of that. Now we have this consumer, and we can just call accept and pass it to builder. And then the builder will be initialized, all the structure will be initialized in the builder by the consumer, right? So after the call, after the accept call, we actually will be able to call the build method and just return it. So in essence, this is what will be creating our client here. But we need to pass in some kind of implementation. Since we are in Kotlin, we can actually do it like this. Object, consumer, client builder, and have to implement the member, the interface right here. So what should be here? Obviously, we have this code already written, and here it is. We just move it inside the block, rename this guy to builder. Oops. And that's it. It already compiles, right? So we just remove this client, and we don't need the builder outside the block anymore. And we have a new kind of nesting there, but we are still not winning anything. The same code is inside that block. Actually, IntelliJ already shows us that we can do something about it. You probably don't see it on the projector, but it underlines this line here. It warns you about something, not really warns you, but suggests you something. It says that you can convert it to Lambda, right? So what if we do that? Boom. And after we do that, it actually suggests that we don't need a generic parameter either. And if we proceed further, we know that if it's a single parameter inside the Lambda, we can actually rename it to it and actually omit it, right? And you see, I just saved some characters again, right? If we proceed further, we are going to start winning more and more characters, and the code will be shrinking more and more. So one thing that probably annoys here is that I have to repeat it all the time, right? What if I didn't have to do it? Okay, let's actually convert the consumer to a Lambda instead. So instead of taking the consumer, we could actually use a Lambda as a parameter, and that Lambda takes client builder as an argument and returns unit, basically nothing, because we don't really need anything from it. And since we have changed this parameter to be a kind of first-class function, we don't really have to call the accept anymore. It's enough to just call it like this, right? Now we don't really need a consumer. And now we have like a Lambda, and IDE tells us that if it's a last argument in the method argument list, we can actually move it out from the braces. So we don't need braces. But we still have this it somewhere. However, how could we change it, right? So in here, if I'm inside this block, I would like it to be without it, but it means that I have to call this first name in the context of client builder. So instead of passing in a Lambda, I can actually pass in extension Lambda, which is a Lambda with receiver. And now, magically, this call or reference to the first name belongs to the client builder. So if I enable the hints, show the hints, I see that inside this block, everything that is called, it belongs actually to the context of client builder. So I can safely remove those it calls, right? And suddenly we see that we already have these calls, those assignments, kind of on the top level, right? What if I wanted to do the same trick to the nested calls in here, right? Let's try the same. So we are in the context of the client builder. What if we add a new method to the client builder so that we get into the context of Twitter builder instead, right? Client builder. The way we can do it is to add a new method, and let's see. I don't remember exactly. So the goal here for me is to get a structure like this one instead. So I don't need those calls, and I would like it to be like this, right? So what if I use something like this? T, which is a Twitter, because we want it to be called inside a Twitter builder context, right? Unit. And the extension, you see it already compiles, right? The thing we need to do is to initialize the builder inside the client builder. If we go to the definition, you will see that here we have this set Twitter, right? This is what we are initializing right now with this call. So if I click on this one, it will be the set Twitter call, right? So in here, we just need to create this Twitter builder, the new instance of it, but we need to apply this block somehow. And as I said, if we need to apply, we just call this method, right? And we call the build. Are you familiar with apply method, what it is? Yes? Cool stuff, right? So I don't have to explain. Or for those who don't know, you can go to the definition and see that apply method is actually an extension method to any type in Kotlin, and it just calls the blocker and returns itself. Nothing special, very simple. So with this call, we are going to set the Twitter for the client builder. And you see it compiles, right? Everything is fine. And the only thing that is left is the company. So we can do the same trick again, and just let's copy and paste here. It's not shameful to do copy pasting. So we are going to have this company method call instead, and then company builder with the extension, and initialize the company field. So and call company builder as well from here. And the only thing that is left is to actually do it like this. Done. And we don't need this line. Boom. So what is left? We have this guy, right? So if I just to verify, what if I'm cheating here? So just to verify, let's execute, and we have the same line that we got before. So we went all the way from, let's see, let's compare split vertically. What is it doing? Okay, whatever. Example. So we went from this kind of code to this kind of code. For this small example, we are not really winning anything, but I think it's a little bit readable, more readable than the previous example. And as the code scales and as we have more code to write, it is actually important to make a sense of the code right after you start watching at it, right? So do I agree or not? Say if you don't agree. You don't agree. I mean, it's fine to disagree. I mean, like this is the initial code is something that we got used to over the years, right? Everybody can read it. It's familiar to everyone. But for special kinds of code, like generating object structures, creating configurations, creating special scripts, this kind of approach totally makes sense. I mean, in total, currently, if I compare the number of characters, probably I didn't win anything. Maybe I lost something, even because I extracted all this logic in pretty fancy syntax sugar, which is actually unique to Kotlin. I don't think you have it in other languages like this. So it might be a little bit unfamiliar, but the benefit of it is that actually if I take this all out and I go to some external file and have it here, so I have moved it into a library now, right? So those examples that I showed you, those are libraries. You can just bring in the library 1, library 2, library 3, and start intermixing those new vocabulary sets in your program and make the code even more readable. So the benefit here is from reuse, not from the fact that you just created a fancy vocabulary and a bunch of functions in one single place and your colleagues are now forced to read it. The benefit is that you have it as a reusable code, right? If you have to repeatedly write this kind of code. All right. How much time did I spend? Like already 35 minutes, right? This is the whole point, actually, that I wanted to explain. I have a few other examples that I've been showing in the slides if you haven't seen it, but as I understand, a lot of people have seen it anyway, so I don't think it's worth showing. Another little example that I have, I will not be typing it all the way, is it was just an exercise for myself. So the use case is pretty much the same. I have a few classes, a calendar. Let's say I'm modeling an events calendar. Right, so I have a calendar, I have a list of events assigned to that calendar. Every event has a name and a date. Just a very minimal model there. Right, how could I create the same structure? So basically I could use the same tricks, but there are some little things that are different. So the code is pretty much the same in Java, right? Again, I can create a top level project. I have to create these event objects and then add to the calendar. And in the Kotlin code, again, again I have extension methods everywhere. But one thing that is different here is that I'm working with dates, right? And let me see. So if I don't do anything about the dates, I have to write pretty long lines. Okay, I could probably create some utility functions, but extension methods are essentially utility functions that you are adding. But compare those two lines, right? So 11th of December, or you have to pass in the numbers, plus this is one really weird place that the month is actually started from 0. So the December is actually number 11. Of course, you can actually write the normal December, right? Month December, but the value is 11. So what I did here is I added the December extension function to the integer class here and made it an infix function, because if you have one argument, you can convert it to infix, and then you don't have to write the dot and the braces, right? So I get this 11th of December 2018, and then by continuing doing it on adding the extension functions, I could, so this December call creates a local date because I don't have the time, so I only have the date, like the day, the month, the year, and it's only possible to create a local date. But if I want to add time, I need to somehow pass it in, and unfortunately I didn't do my homework like till the end, so I didn't have time to create it without the braces, because then operator precedence is important, how you do it and so on. So I thought, what if I just create a pair, and instead of doing 14.2, which would be the same, right? I just have hours and create a pair out of that and add the add extension method to local date, and set the time to the result of the previous operation. So this way I get this kind of not so nice probably syntax, but this is a halfway there. It could be better, I think. So like just a little thing here is that we are using infix functions here, right, to achieve this kind of effect without having to put the dot and put the braces everywhere. Okay, that's another little example. Yeah?
It's getting pretty interesting, like, but it can get quite messy when you...
Yeah, you have to be careful.
Integer, for example. Like, is it...
It's not a good practice to pollute the global namespace.
Yeah, I just, like, one question, like, can I create, like, infix extension method, which can be used only after importing, like, I don't know, like, local thing?
Yeah, this is the point. You could extract it into the library and only use it where you actually need this kind of code, right? So you will not be polluting the global namespace everywhere, but just in that little piece of code.
Sounds good.
Yeah. So if I had this as a library, then that's nice, right?
So then it works like that. You just like do import some stuff.
Yep.
And then I see like integer dot something.
Exactly.
Cool.
Right. Okay. So those are the examples I wanted to show and give you the idea of how you actually can get this kind of nesting. I could probably show you more examples, real-life examples from the projects. So for instance, I have a pipeline in TeamCity defined in Kotlin DSL. Are you familiar with TeamCity? Someone? It's not so popular project of JetBrains, so I totally understand that you haven't seen it before, but I probably even have it running. Let me see. localhost 88. Okay, it doesn't, but I can start it and show you that. Servers, TeamCity, bin run start. It takes a minute or so, and while it's starting, I will explain you the DSL a little bit. So we have this top level function, which is project. We obviously have imports, right? So it comes from one of the imports. And this is how the IDE currently knows how to do autocompletes, refactoring, type suggestion, and so on. And then inside the project, as you can see, we are in the context of the project. We are starting to call those relevant methods. So for instance, we define the VCS routes. A VCS route is a repository, right? So it has a name, it has a URL. In my case, it's Git. I probably should start my local Git repository as well. Oh, let me see. It's probably here. Yeah. So this is the command I get Git to run. Okay, so it's running. I can specify the branches which I want to monitor, and then if I really want to, I can specify the authentication method, for instance, and some other properties as well. Okay, so I have a bunch of those defined and attached to the project. Then I have a build type. A build type is a build configuration. If you used Jenkins before, it's a job or an item, the same thing, right? It has an ID, it has a name. I tell it to monitor a repository. I define which artifacts it has to publish. So once the build is complete, which files I should expose. The build steps, in my case, it's a Maven project. Triggers, if I wanted to trigger on any change in the repository, and then dependencies between the build jobs. So say I'm building a library first, then an application, then I have some other configurations that start testing in parallel, maybe if I have many of them. And then I could have packaging and deployment at the end. So actually should remove this one. So I have a bunch of those as well, like a development configurations, then testing configuration, which also has dependencies and like rules, what to test and so on. And then at the very end, I have a deployment configuration, which will have a deploy button in the UI. And now I probably have TeamCity already running. Some tests are failing maybe. But anyways, this is the UI I get by defining these structures in Kotlin DSL. So if I go and check, for instance, the settings, so there are version settings, and in TeamCity is kind of very sophisticated server. There's a lot of features, so sometimes it looks like a spaceship control panel, but here we can say that synchronization is enabled on some VCS, like in some repositories. So this is where it stores the settings, which I'm changing and committing. And once I commit, the trigger will see that there's a new configuration for the pipeline. Pull in the changes, reconfigure itself, add new build configurations to the UI, and we get, let's see. We get this structure, right? So we have sub-projects, and under each project we have some set of build configurations. You see we have a deploy button for the deploy configuration, and we can also see what were the build chains. So for instance, so we have the first build, second build, a few concurrent builds, and we can see that this chain was building until this place, so that I can start this from the run button. But all this is configured through Kotlin DSL, right? So we implemented it for us. There is still a lot of work to do to polish it and make it even nicer, like so that we could probably get rid of this kind of declarations, like declaring an object, and it's in some places it's already possible, but not everywhere. Some API calls expect the type instead of a value, so we need to do some work there still, but it's pretty easy to configure now, and a lot of projects internally, I would say almost everybody is using Kotlin DSL to build IDEA, Kotlin itself, all the other IDEs, all the other products, TeamCity itself. So, any questions yet?
Yeah, for the first example, the extracted file you created, it was like adapter to that library. So is it now prone to the library change? If implements build method, will it break?
Wait, can you repeat? Like, what do you actually mean? What is the question actually?
You know, show the file that you extracted in first example.
Oh, this one?
Yeah.
Yeah.
So you created somehow, we can call it like adapter to the library, yeah, for the builders.
Well, in this package, currently it's in a namespace of that package. I can just call it. Yeah.
But if that objects or classes change, should I change also? Would I be needed to change something in here?
Most likely, yes. If let's say the host library that I'm working on, the Java classes, and you pull in the new version of it, and then they rename the company field to firm, for instance, right? So this we are using these classes, then it won't compile anymore. Of course, the company is not there. The field is named differently, so we have to update it.
And if they implement build method, would be there a conflict?
That's their build method.
It's already there.
Yeah, it's already there. So if they implement company method in the builder class, that would be interesting to see, but most likely it will be compilation error. So public, what did it return? Company doesn't return anything, takes an interface, but okay, void, a company, let's see.
It should return company.
Sorry?
It should
Oh.
return company.
Oh, okay, yeah. Sorry. Yes, exactly.
And I think you would have to also match the arguments, which I don't think you can do from Java.
Let's try. I don't know. Maybe we can. Okay, so yeah, it would be pretty hard actually.
You would have
Right
to
now,
match the extension signature.
It should somehow reverse engineer it, and yeah, so it's the probability is probably not so high to actually collide like this.
Can you paste Kotlin to Java?
I can try. No,
Would IDEA convert it?
I don't think so. No, I haven't seen this kind of
So
feature.
it's one way, right?
Yeah.
Hashing on purpose.
Evil. Yes. Okay. Yeah.
New Kotlin compiler.
That would be fun. Yeah.
So the new code, the client DSL you created, I'm wondering if it wouldn't be a hell to debug.
Well, it would be if your IDE did not support it. Yes, it would be a hell.
If I now wanted to step through the creation of the...
You see, it's not a DSL, it's syntactic sugar, the same way, and Kotlin is debuggable, so it's really a valid Kotlin code, so you can step through extension methods and
My
everything.
question is if we didn't use too much of syntactic sugar to be comfortably debugged or analyzed.
I don't see how you can achieve that, actually. It would be a nice exercise to break the IDE and...
Not the IDE, but the programmer.
Okay. Well, I don't see how it could be done. Like, what should be the level of sweetness to make it unreadable or something, because there's a normal methods. It's just the are okay. You can go nuts with every feature,
There's
with
like
every
a
language.
lot of applying lambdas that can be confusing.
I think the real problem is when you try to read this code in a plain text editor, which doesn't show you those gray type hints, right? Those are added by IDEA.
Well, I think it's the matter of taste, because yeah, in this case, it's a small example. It probably gets rid of that. Yeah, do not show the type hints. But if it's a lot of code, I'm probably interested in seeing those, and they are helping me really, right? So without those, it is probably harder.
But sometimes you read the code using GitHub or some online tool, and you don't see these type.
Yeah, probably the only recipe here would be, or the only guide would be, to actually think hard of those methods, how you name them. Maybe it would help this kind of readability. It always helps, right, in Java as well. But yeah, reading the code in the IDE is much better.
What about documentation?
Documentation is always a good question. There's always one who asks about documentation, but Kotlin documentation is really nice.
Speaking about DSL, would we generate something like, well, not Java doc level, but something which is easily...
If I had internet connection, I would show you. There is a chapter on Typesafe Builders. Actually, this is a Typesafe Builder concept in Kotlin. And there is a chapter in the documentation how you achieve that and what are the language features that enable it. Right? And it's obviously, it's also described in the book. And there are a few books. So one thing, right? So if you have something to remember, if you want to remember something from this talk, remember about extension lambdas. Right? This is the most important feature of the language to enable the DSL. Actually, it's not. I don't like the term DSL because it's kind of a fake. We are not developing a new language. We are just using the language features to create kind of those nesting structures. And I don't like to think it of a new DSL or something. So there are some books. Atomic Kotlin was just released, and Kotlin in Action. I'm pretty sure you all know about those. And we also launched the course, the online course at Coursera. We also have courses on some other resources, but this is the only English, in English language, the only one that I know. And yeah, you probably know all other resources as well, like try Kotlin Lang and the Slack, the official Slack of Kotlin. So the question was about documentation. It's pretty well documented.
It was more about generating documentation out of the code. So the DSL. It's like if I want to share the DSL with my colleagues. Or
Okay. That's a very good question. I don't know. I don't have a recipe for that. It basically works as a normal Java doc in most cases. In Kotlin DSL for TeamCity, we basically use this approach, right? So it's just a vocabulary, it's just a method name that you expose for the users, and it just needs a normal Kotlin doc this time. All right.
One more thing from here.
Yeah.
All these things are actually making things more readable. On one side, and on another side, it's hiding behavior. Because there is all these builders.
You mean how it does something,
so
right?
Two things, and so this only thing for which this thing is good for is for configurations, type-safe configurations, all those declarative style things, or is it possible also to use this for some useful behaviors?
Yes. For instance, let me see if I have it here. Ktor, right? Probably this is the first thing that comes to my mind. So there was an example. It's just too small, probably. Jerry. Yeah, this one is a little bit more sophisticated, right? So it's not a configuration, or kind of a configuration, right? But they are actually executing something, right? So respond HTML. The call is responding HTML. It's not just configuration or just something that generates objects anymore. It really executes.
Right. Yeah, this could be really cool, actually. You don't actually need a dependency injection generator because you can do that. Like
they have an example where they used Kotlin, another DSL-like library for dependency injection in Kotlin. If I could find it, let me see. Yeah, there's the one. So they have like create a Kotlin app. Okay, I didn't import the class path, but I don't want to start importing it. So as you can see, it's already like, it also creates a level of abstraction for dependency injection if you really need it. Depends on your requirements, but it is possible, right? Okay. More questions? Maybe I can show you a few tricks from IntelliJ if you want. No? Okay. Maybe I convince some people here who are not using it yet. Okay. Yeah, there's a question.
I would like to add to the last question because I share the concern. The code is amazingly readable, but anything else I wouldn't want to do with it would be harder. Like to analyze the code or understand what it actually really does.
Right.
It's now much harder. But then there's the question of the use case. You need to use it on something you do a lot, and then there's a big probability you have it debugged and went through many times, and it pays off. If it's just 2-3 cases, it will probably just kick you in the butt later when something breaks.
Okay. Well, as I was showing TeamCity example, for instance, right? You don't really want to figure out how to execute a Maven build step in TeamCity manually, right? The DSL that we provide to you is much better and much more convenient. And as a user, you don't want to think about the internals. You don't want you just want these tasks to be, executed. You just want this job to be done, and that's it. And forget about it, right? And this is why I'm saying that it's mostly for libraries. Like if you just start writing your own DSLs inside your application for one use case, it's probably not worth it. Okay. All right. Who, like you two used Eclipse, right? Who else? Like raise the hands, everybody. Okay. And keep it up until the end of our meeting for the punishment. Okay. I don't know. Should I really show something in the IDE? No? Yes? Okay, let's do a small example here. Why not? Standalone. Well, I said I'm really bad in typing, but I tried to type a little bit for you. So, a very small example that we could start typing in. Then you probably can relate to. It's not the point if the code that we are going to write is going to be correct or not. The point is what the IDE does for us, right? So the scenario here is like this. We are going to read something from the file, read the lines from the file, do something with them, print them out, right? Nothing special. So to read the file, to read the text file, what do we need to do? We need a Bufferedreader. As you can see, the completion works a little bit differently than in Eclipse already from the first thing. In Eclipse, I would have to write this, one capital letter more. Small thing, but it's already different. Okay, suggesting the variable names. Now, normally we would write something like new. After Kotlin, it feels so weird. Now I have to write the new keyword. And okay, so auto-completion. gets us some weird list. And this list is the same in Eclipse as well. Now you get, for some reason, the IDs give you those array types in auto-completion, but we can actually get a clean auto-completion as well, because in IntelliJ there is also a smart auto-completion that checks what kind of type we have on the left-hand side. And one little thing here, even experienced IntelliJ users don't pay attention usually to the small things that are available in the IDE. You see this little text here? Probably no one read it from you. Like, did anyone read it?
Which one?
Never. This very small one.
Yes.
Yeah. So normally people just don't notice it. So there's always some kind of suggestion what kind of shortcut you can use or what you can do better in that context. But anyways, we are reading the file reader. Maybe we need a file. Maybe we do something like lines.txt. And then this file is like, okay, I didn't fix the error. How do I jump to the red error? Normally I would like press the control and use the arrow keys or use the mouse. Is there anything is there any better way to do that? There is F2 and I jump to the place which I want to fix, right? Alt enter, add the exception. And now one thing is that this too many nesting structures, right? In one line I probably want to extract a variable, or if I go to that string I get a even better auto-suggest how to extract it, but anyways it doesn't matter right now. I extract something, it's already shorter. So we were typing the code from left to right. What if we try typing from right to left? What do I mean here? So we are going to read the file line by line. Where do we store those lines? Let's store them in a list, right? So I need an array list for that, and why not? Array list, and it will be a list of strings, and I have the right-hand side now, and I can use refactoring to get the left-hand side, right? This is a nice thing. Notice what happened here. I had a generic parameter on the right as a string. It's gone right now, right? So it's not on the right anymore. It's now on the left only. It suggests me that it will be a list of strings, so suggest me the right name. If I want to, I can click a shortcut to define this variable as final. You can see that there is a pop-up, and on the bottom of the auto-suggestion box, I can see also that it suggests if I want to change the type from list to something else, maybe I want it to be an array list for some reason. I don't like interfaces and I want to program against concrete implementations, then I can type Shift Tab and jump there and select whatever type I want, right? Okay. Good. So we have the next statement. What shall we do to start reading the file? Right. While line. So we probably need a line. String line. Okay, I forgot semicolon again. You know why. And now, what kind of method should I call from the Bufferedreader to read a line? Read line, right? So please talk to me. But I don't remember that. I'm too lazy. I will just call the auto-completion twice and get the correct method because I'm too lazy to type and figure it out. Good. So it shouldn't be null and then call the auto-completion again for the statement. So I get those curly braces automatically. And now suddenly I forgot to fix the error on the line. We know that we can go there with F2, jump there. And now it's an IO exception, right? So what does the IDE do if we try to fix it. It will add a new exception into the signature, right? But IO exception is a more general for file not found exception, so it doesn't make sense to have them both. And it will replace it with IO exception. Again, the difference with Eclipse is that it will keep both exceptions in the signature in this case. All right, so we have a line, and we want to put it into the list of strings, right? One type of auto-completion that I learned some years ago in IntelliJ and just cannot live without it is completion by the letter and the dot. So if I want to call an add method on the list of strings. What should I do? I type s.a, and a very high probability is that I will get the right answer within a couple of first entries in the auto-suggestion box. In this case, it will be the first one, right? Line, done, and complete the statement. Nice, isn't it? But it's not now. But what if I wanted to add only the lines that are not empty, right? There's a little shortcut that allows me to surround with live templates. Do you know what live templates are? Not too many people, actually. So we have to learn about live templates here. Anyways, so if I use the if live template, it will surround this line with if, and now I want to check if it's empty or not. Basically, it should be not empty, right? So the line is empty, and what I can do now is to not just complete and jump back and put the exclamation mark, but instead I can just put the exclamation mark, not hit enter, and it will put the exclamation mark to the beginning, complete the statement, and put the cursor back to the correct place. Boom. Okay, a little bit about live templates, if so many people don't know about it. So the very first live template that normal Java developer writes is this PSVM. PSVM. So you get a main method, right? There is a bunch of them, and there are some popular ones like printing out statements, like system out, south M, south V, south P for different use cases. But how do you know which abbreviation you should type? So there is like a Command J or Control J shortcut that gives you a full list of those. And you can search. So if I want to iterate, for instance, iterate. So it searches by the description and gives you whatever you need, and you can, find whatever you need. And let's see. So we have a list. Now we have read all the lines into the array list. And, well, probably for some reason we want to convert it to an array of strings. So there are two ways to do that in here. Either I'm using the 2R live template, and then say that strings done, extract it into a variable, and IntelliJ will actually tell me that I'm doing something wrong. Actually, IntelliJ did something wrong for me, but now blames me. You see, it gives me a warning that toArray is not correctly implemented. The reason is that this was the correct implementation before Java 1.7 or Java 1.6. Today, you don't really need to specify the size of the array for this conversion. There is explanation for that. I will not read it because it takes time. So you can just pass it in like this. The reason is that the toArray call was intrinsified in JDK. So this one is actually faster. Or another way is to, what was the another way? Well, we don't do that anyways. So let's let's assume that this is what we wanted to get. So fix it again. All right, so and now we have the same result but inside the array of strings. And what if I would like to sort it? Nice thing. I definitely know that there is a sort method, but in which class I don't remember. So I start typing sort, and in IntelliJ I already showed you that it's possible to call the autocompletion twice. So there is autocompletion for static methods that searches for static methods inside the project. And in this case, I can do that. So I call the completion, normal completion twice. So control space space, and I get all the sort methods, all the static sort methods from my project. And I probably need this one, sort array, and that's it. Boom. Right. So we have the sorted array. We can again use alive templates, for instance, to iterate it. Iter on the array, print it out. Right? Very simple. So how many new things you have learned? Have anyone from IntelliJ users learned at least one thing in this little example? How experienced you are with IntelliJ? You use, you just use it.
Can I have
Good.
a suggestion?
Yes.
You have a nice way to wrap the entire method in try with resources to close the reader after.
Oh, I forgot about that. Thank you. So, boom. Okay. Anyways,
No,
it's not about.
resources.
Yeah, I understand. It's not the point of writing the correct code here. Yeah. Okay, so there are a few other things. If you have learned now something, I hope you will learn something from this little example as well. So here's like a data flow class I have. It has a main method. It has a method call which is flow, then do something with the ID, then there is a split into two methods, log the ID, go back, register, send to DB, go back, send to the queue, JMS send, JMS act, whatever. Does it remind you something? When there is a problem and you start debugging it, and then a variable or some field goes through the code and you kind of debug it like very deep into this code, and then you forget where did it come from. Sounds familiar? Right. So there is this thing in the in IntelliJ called data flow to here and data flow from here. So if I want to know where did this ID come from, data flow from to here, because we are deep inside our code. Analyze data flow from here, and it gives me the path. How did it go, from where this ID came to my call where I'm standing right now. And as you can see, it actually gets me back to this part. So it actually came as an argument to our application. And on purpose, I'm not passing this argument to the flow method. Instead, I'm passing it as an argument to the constructor and assigning it to a field. Right? So, like this. And it still is able to find that, hey, dude, this is where it came from. And we can do it vice versa. Right? So, from instance, where will it go? Like, it will show us all the splits. Data flow from here. And it also will show us, you see, like it splits where we log the ID and register the ID, send it to database and send it to queue, and we know how our value will be propagated through the code. Obviously, it's a static code analysis. In dynamic application, if you use aspects or something like bytecode manipulation libraries, it will not be able to actually show you that is happening something there. But on a static code, it analyzes pretty well. Is it something new?
This is not the same thing as file usages.
No, no, it's not. It has the context. I want to know where this variable goes from this part.
Will it work in dependency injection like Spring through components that are outward?
That's a good question. I don't have an example to try it, but no, I don't think so. Because Spring is too dynamic itself.
It depends on your code.
Well, but the main use case for me when I was using it was that I needed like to debug some data flow code, and usually it doesn't have like the dynamic things in between besides aspects, right? So it might happen that some aspect goes in the middle somewhere, intercepts the method call, and then kind of adds another branch to the handling. What else do we have here? Okay, this one. Okay, so maybe you have noticed I don't have tabs. I don't have anything else besides the editor. Do you use the setup with tabs? Do you really open all kind of toolbars? How do you navigate? I think one of the key strengths of the IDE is that it allows you to navigate efficiently. So this is how I work actually. I don't have anything else normally. Sometimes I open the project tree, but it's just a habit. Normally I wouldn't need to do that even. I could probably do something like this, right? Get the navigation bar, because I get most of the actions from here as well. So I just can stay on a clean screen and just focus on the code. How do I navigate between the files? Command E, I get all the files that I've been recently opening, and some extra menus as well if I really need those, like a terminal, for instance, if I need to switch between those. If I need to find recently edited files, we also have a shortcut for that, right? If I need to open those toolbars that are on the side, normally double shift or double command takes me there, and I can just open it. And some of them actually have a shortcut, like favorites, command 7 gives me the structure, but I don't remember using it even because there is a better pop-up which gives me, let me open some more relevant file, for instance data flow instead, command F12, right? So this is something that you know probably, right? So there's a lot of good things for navigation, and also navigation through the code as well. So like command B, but those things you know. Okay, so I showed you just the basic things right now. There are some really advanced things that normal developers don't need, or need really, really seldom, like structural search, for instance. Have you seen it? Have you seen how it works? So for instance, you are searching for something in the code, and what you can do is just execute the normal search for a string, right? What if you are looking for a specific implementation or for specific code snippet? Let's say I'm looking for a code snippet where my code implements some sort of an interface, and inside the implementing method, I call some sort of other API, right? You cannot do that with a textual search at all. There is a structural search and replace in IDEA. So you can just search, or you can also replace it. And IDEA provides you some of the features out of the box, like finding the patterns that could be converted automatically, and it uses this kind of trick. So I can show you the example here. Let me see if I have. Oh, I had it here, local. Or did I? I probably should find. I probably deleted the example, but main. I am not sure if it's the right project even, but we can check the local history, of course, for the file that we changed. History. And no, so it was somewhere else. But anyways, like there is like this feature. I don't want to demonstrate; it's too complicated. The guys are currently working to improve the UI so that it's a little bit easier to use. But the point is, you can get all kind of existing templates from here. Like, give me all the fields of classes. Boom. So it gives you this kind of a template where you define filters. So every value in between the dollars is actually a filter, which I kind of specify on the right. And if I execute the search, it gives me all the fields, right, in my project. So it finds all the fields and all the classes. This is like a very dumb example, but I myself needed it for the use case where I wanted to find an example of an implementation inside IntelliJ code. It's very big. It's very hard to find something, and just textual search gave me like, it was a popular interface as well. So it was giving me like 1,000 search hits. And I wanted like a very specific example. I wanted to see how this interface is used with some API, to call some API. So as I was able to specify, give me all those all subclasses of this interface where inside the interface we call a network or whatever, like whatever API, right? And it gave me 2 examples, much better than 1,000. Much easier to check and find what you actually need. Another cool feature probably is this language injection. Do you know about language injection? Okay, cool. So I can take any string here and say I want it to be recognized as some language, right? So there are 2 ways to do that. You can stay on the string and call the alt-enter and say inject language reference. I don't really like this approach myself, because then it saves this place, the string, inside the settings under .idea directory, and basically your colleagues will be, if you don't put this .idea directory into version control, then your colleagues will not get this kind of benefit. Instead, I actually like this approach more, so that I'm using a comment and saying that language equals JavaScript, and it immediately recognizes it and as a JavaScript string, and even with those /n and pluses, and gives me syntax highlight, gives me auto-completion and everything. And I can also start editing it as a fragment if I don't want to edit it in oops. So as you can see, right? Same for HTML and stuff.
So just a question here. So if I'm using Nascode, for example, will it autocomplete?
Yes.
Based on the code in the project?
Yeah. Same for HTML, for instance. If we had string HTML equals, and I want to say that this is the language equals HTML, and you see it already starts auto-completing it, and I can actually use the fragment again and start doing something like that. Heads title. Oops. Body, table, td, tr, no, tr times 3, td times 2, and get the table, maybe, yeah, done. And as you can see, it's formatting for me as well. Not the biggest use case, but pretty nice, right? Okay. So I think we can finish now. It has been 90 minutes of me talking, and I'm not the most entertaining speaker as well. So we have a bunch of stickers here, and we have those brains because we are JetBrains, and yo-yos. Who is the fastest can get some. And thank you for your attention and for coming here.
Thank you.